Hello everyone. In today's video, we are going to talk about MLOps, machine learning operations, where I'll try my best to make you understand what is MLOps. So yeah, let's get started. So how this video is divided? First, we'll talk about prerequisites and the machine learning lifecycle. Why and what is MLOps? MLOps culture or MLOps practice, architecture design which we are going to implement in this video, and finally last but not least we'll make our hands dirty by seeing an example, how we can automate the model deployment. And the prerequisites, like it's good if you know the basics of Docker. In case if not, watch this video. I made a almost 30 plus minutes of video where I talked about Docker, what is Docker. I took a simple example for deployment, Docker container. The basic of Jenkins, no worries if you're not aware about it. We'll just talk very basics what is Jenkins, in our video. So before we talk about what is MLOps, why we need MLOps, let's try to understand the typical machine learning lifecycle, which is very important to understand before we jump into our actual topic. So if you see, the first step would be data engineering, a typical data pre-processing, where most of the data scientists, will spend time here. Once they make the data perfect, and the next step would be training your model. Maybe we try with different machine learning algorithms with different set of hyperparameters, and finally we'll find the best model. Once we find the best model, the next step would be obviously deployment. We are not done yet. So once we deploy it, we have to check how our model is performing in the production. Right? We do model monitoring. Maybe after a week or after a couple of months, we found our model is not performing well. Obviously, we have to retrain our model. The cycle starts again from the first. So come back to the data engineering, do the data pre-processing, find the best model, deploy it, and model monitoring. Hope you understand this, the typical machine learning life cycle. So this is very important to understand, as I said, before we jump into our topic. So next, still, we are not at what is MLOps. It's good. We'll just try to understand some problems, what we face, during this data science life cycle. So one of the major problems, obviously, the machine learning model deployment. According to a recent survey, 55% of the companies have not deployed a machine learning model. There could be multiple reasons. Maybe they don't have proper data. Even if they have data, they don't not sure how to use it. Maybe the machine learning is not the right set for their business use case. Could be multiple reasons. Models do not make it to production, and if they do, they break. Okay. Teams do not have reusable or reproducible component, and their process involve difficulties in hands-off between the data scientist and IT. This is a very crucial part. Maybe I'll touch upon this in our upcoming slides, but one point which we need to understand is team do not have a reusable or reproducible component. Just remember this point, we'll discuss in our upcoming slides. Deployment, scaling, versioning efforts still creates a headache. Though this is not a specific problem for ML, machine learning model deployment, this is a common problem with any kind of software deployment, right? A generic deployment, I can say. Now, our main topic, what is MLOps? MLOps is a set of practice for collaboration and communication between data scientists and operation teams. A typical DevOps, statement, right? But yes, so there should be a proper communication between the developers and operation. In our case, the machine learning developers and the operation team. Okay, this is very important point. By applying these practices, increase the quality, simplifies the management process, and automate the deployment of machine learning and deep learning models in large scale production environment and monitor its performance in the real time. If you see, the name itself says, right, ML Ops. So when the ops team will involve during the deployment and migration. So ML Ops is more about how do you deploy your model, how do you monitor your model, how do you automatically retrain your model and the deployment again. I can say it's more of automated the deployment of your model, right? So it could be like automatic retraining, as we just seen here, right? If you see, automatic retraining, if my model is not performing well, retrain it automatically with a very minimal human intervention here. Right, that's what I mean by automated, right? So when I say what is MLOps in simple terms, we should fill all these problems. We should be able to solve all these problems. How we solve? Okay, we'll discuss. If you see, it's not just about the tools or technologies. What I mean is MLOps is not just about the tools or technologies. It's about the practice. It's about the culture. What I mean by the practice or culture here, if you read this point again, team do not have reusable or reproducible component. Let's say I write some logic, and in case if I am not able to reuse it, how can I retrain it automatically? I'll come to that point now. If you see a typical screenshot of a Jupyter notebook where the data scientist writes some code, assume this is some pre-processing code. Do you really think this is a reusable code? No. It's not just about the Jupyter notebook, right? It's more about the reusable component. Let me make it more clear. If you see, this is our actual Jupyter notebook screenshot which is seen before. And how about I write like this, right? Whatever the logic which I write here, usually if I want to run this, I should say shift enter. So if I have 100 cells, I have to press 100 times shift enter. Doesn't make any sense, right? I cannot automate this, right? If you see, MLOps is more of automating your machine learning model deployments, right? That can be done only if you follow the certain standards or certain practices, right? That's what I mean by the culture here, right? Because if you see, for deploying, for machine learning model deployment, we don't need any new technology, right? If you see a typical REST APIs, we can use the same technique here to deploy ML models. And that's what I mean here. That's what I mean here is it's not about the tools and technologies. It's about how you code it in such a way that can be reused. Okay. Now, I'm just moving to the next slide. Yes. If you see, if I can write my code like this particular piece of code, I can put in one container, right? Maybe in a Docker container, right? And whenever it comes to the retraining, automatic retraining, right? My model is not performing well, trigger. It will come and trigger my container, Docker container, where my data pre-processing code is there. Once the data pre-processing logic is completed, right? That pre-processed data will be written in S3. I mean, I took an example of S3, it could be any storage, right? And once the data is written in S3 or any some other place, then it will automatically trigger your model, machine learning algorithms, where it will try again, different models with different set of hyperparameters. Then the best model will be pushed to your model registry. Typically, model registry is the place where your trained model is stored. It can also be used as a versioning or whatever you call. Once your model is pushed in a model registry, then we can, of course, this is automated process. So we have one more pipeline. What it does is get the latest model, right? We should write the inferencing logic, right? Like typically what inferencing logic contains, right? Reading the model, right? And getting the input, the request, and do the basic data pre-processing that is required for your trained model to predict. That the typical logic will have, and deploy it, and the traditional process starts. I mean, the typical process start like monitoring it, and if something wrong, come back. Everything is automated here. Maybe at this step, we can involve the human intervention to see if he can deploy the model or not, if he want to deploy the model or not. Instead of making it 100% automated, it doesn't make any sense if you ask me, right? Maybe there must be the business person who should approve this model, whether he is okay to deploy this model or not. Again, it's just a click, the same steps will process. All this can be happen only if we can write a reusable code. That is very, very important, and that's what I mean by a practice or a culture. Right? Now, if you see, there are three types of machine learning deployment. One is real time, which we are going to see in some time. The second one is a batch. Like, you know what is real time, right? Like, I get a request, I want the response immediately. Whether, like, for example, whether it's a good customer or a bad customer, send the response immediately. When you talk about the batch, maybe weather forecasting, sales forecasting, whatever, right? Typically, that is batch that happens either in the weekend or over the night, whatever. The third one is edge. Typically, that comes whenever there is IoT, Internet of Things involved. It doesn't make you sense to deploy your model somewhere else and your IoT device is here, right? So we'll be deploying a model where my IoT device is here, so that the latency will be less. And of course, we can also deploy, ML models in the mobile devices. Okay. Now, as I said, it's time to make your hands dirty. So I'll just quickly walk through the architecture which I'm planning to implement. So this is obviously mainly for deploying your, the machine learning model. So here I'm not using any registry as I just shown you here, right? I'm just pushing my code along with the trained model in the GitHub. Ideally, pushing your trained model in GitHub is not the right choice. It always has to be in the model registry or somewhere in the secure, right? Definitely not in the Git. Just for an understanding, like, I'm just, for this demo, I'm keeping it in the Git. So as soon as I push my code, so my Jenkins pipeline will trigger. In case if you're not sure, Jenkins is mostly used in the DevOps world. Of course, if you're in the MLOPS world, it's more of continuous deployment, delivery, right? So it has this set of pipelines. If you see, the first thing is it will pull the code from your Git repo, right? And then I write a Python code. It's your choice. You can use the typical Git pipelines. You can write Groovy. You can write shell script. Which are the programming language you're comfortable, we can write those. And as I am more into Python, I write a Python script. What it does is it will build an image, right, based on the code which is being pushed in the GitHub. We'll just quickly see that what is there, right, and it will tag it, and then it will push the code to the Docker Hub, right? Because Docker Hub is it is actually a registry and repository for your Docker images, right? You can say centralized repository. And there is another set of piece of Python code. What it does is it will pull that image, right, and it will generate the Kubernetes ML file automatically. Here, the data scientists need not to worry about writing the Docker file, Kubernetes file, how deployment happens, nothing. With a very basic understanding, what is Docker, a simple Docker file is more than enough. So our Python code will automatically generate a Kubernetes ML file and deploy in your Kubernetes engine. That's it. So one major problem that which I was talking about MLOps is the deployment. We just talk about reusable. We have a easy solution. Make sure we write a function-oriented coding, maybe in simple terms. So another problem is the deployment and scaling. Deployment, anyways, we are automating it, so problem solved. So what I mean by scaling? So we don't know how many requests we'll get, right? Sometimes we'll get sudden spike in the request. How can I scale it? And that's where the Kubernetes helps us, right? So Kubernetes is a container orchestration engine which can scale in and scale out your Docker applications. So in our case, we are deploying 2 containers, right? In case if there is sudden spike in the request, the Kubernetes engine will identify it. and it will spin one more container, right? And in case if something wrong with this container and it is down, right? Your Kubernetes engine is smart enough that it will spin another container automatically, where you are not aware that what is happening behind. You are not even aware that your container is down. It will be everything will be taken care by your Kubernetes engine. And of course, as we are deploying our model on multiple locations or multiple places, right? Technically speaking, we are deploying our model in two different servers. Assume. So obviously, we'll get two APIs, right? And we need a load balancer, right? That also Kubernetes gives for you, right? So one best part about this architecture is when you talk about the Kubernetes and typically containers, right? Kubernetes. The best part is this is a cloud diagnostic. What are the Kubernetes YAML file which I'm generating, which is gonna run in my local system, and the same Kubernetes file will run in our AWS, can run in your GCP, Azure, maybe somewhere in any of the on-premises system. So that's why I want to call this architecture as a cloud agnostic or platform agnostic architecture, right? That will take care of automate of your deployment and the scaling part as well. So you're a bit excited. Okay. So this I'll put this Git link in the video description. I'm not sure if I opened it here. Yes, it is here. Maybe no. We'll see in the Git itself, no problem. Let me open the files. This is a typical Docker file where most of the cases, 99% of the time, your data scientists need not to touch this file. They can take this as a template, right? And keep it in their location where they are writing their inferencing logic. So I'm taking Python 3.7 in case if you want any version, come here and change it. It's not a big deal, right? And I'm just copying my requirement.txt file where I'll keep what are the packages I need to, install. In our case, I'm using Flask, which is used as a Python REST API microservice service engine, and Unicorn as our application server, you can say. It's a web server typically where you can deploy your Flask application. And of course, I'm using scikit-learn. And then I'm copying it. I'm running my requirement.txt file, and I'm running my the Unicorn server. In case if you're not sure what is Unicorn, what is REST API, I already made those videos. I'll make sure I'll keep that in the description. Please watch it. This is definitely worth watching, right? So then, I'll talk about this configuration file that is important. And this is our typical, simple, the inferencing logic. I'm loading my model, right? This is what I said, right? It's more about writing a proper set of Python code, right? I say it's a practice or culture, right? One function I made to load the model. The second function is used to predict, and this is the third function where it takes the request. I don't have much data pre-processing in games. If you have a lot of data pre-processing, typically if you see NLP models, you have more. I can see compared to the normal, the CSV and all NLP and the image will have more data pre-processing steps. In that case, you can write a separate Python code, do all your data pre-processing logic and import that particular Python code here and import that function here, right? What it does is it is calling this model and then it is calling this predict function. What are the response I'm getting? I'm just sending it back. Sending it to whom? As I said, in our example, we are deploying our model as a real-time, typically REST API. And this inferencing logic should be exposed as a REST API, right? And this is a simple Python file. It does pretty straightforward job. I'm using Flask. As I said, I already made a video. I'll keep that in the description. Watch it. So here I'm just importing this particular Python code, which is my predict.py, where I'm importing input request, this particular function. Obviously, if I call this function, this internally call these two functions, right? Makes sense. And I'm getting the request from my, either I can expose my API as a post or get. Ideally, get is not the right way to expose your models. Always use post. And yeah, that's a simple Python code. That's it. And yeah, the other important thing which I want to talk about is the configuration file. Fine, you want to deploy your model. What name you want me to give to your model? So I'm using Iris dataset. So this again has to fill be by the data scientist. So he's giving the Iris. I mean, what do you call the name of the model that he want to deploy? How many instance that he want to have? So as I just shown here, 2 instance. How many instances? Because he knows, right, how where this application is gonna be used, how many requests he'll get. So based on that, he'll decide what is the RAM, CPU, right? You can also say what are the maximum RAM it can go, maximum CPU it can go, which port I want to expose my API. A typical JSON file configuration that anyone can be filled easily, right? So this is cool. So I think did we left anything here? No, we are good. So what next? Now, okay, good. What we'll try to do is we'll just try to deploy this code to the Jenkins pipeline, and then we'll try to understand what the Python code and the Jenkins pipeline will try to understand after we see the deployment. So I'm using a Minikube here. As I said, I'm using Kubernetes. So typically Kubernetes runs on the cluster. I cannot create a cluster in my local system. So Minikube help us to do for us. Typically speaking, Minikube is meant for your development and for the developer testing, right? So when you go for the QA and production, you have a typical Kubernetes clusters. Of course, as I said, you can run the same set of Kubernetes files there as well. kubectl get pods. Okay. See, pods is a place where your container is deployed, right? So I'm repeating myself again. Pod is the place where my container is deployed. Here I'm running 2 containers. Same, what you call the inferencing logic I deployed in 2 containers. In a Kubernetes world, we can call it 2 pods. SVC is nothing but your service where you obviously have to expose your API. I mean, your models are models deployed in the containers and is an REST API. Right? You need some IPs, and that's where the service comes in place. Let's not much worry about the Kubernetes and all. My intention here is to just give you an idea how you can automate it. Yes, if you see there is nothing here, no resource found in the default namespace. Let me log into the Jenkins. So I need to make sure that particular folder is empty. Jenkins, workspace, MLOPS 1. Yeah, the folder is empty. That's cool. Now, yeah, I also need to open the Docker Hub to see if you see one of the step is to pushing the image to the Docker Hub, right? I'm just trying to give the name as a test. I just hard coded it. So if you see, obviously, right, like if you do multiple deployments, you'll have multiple Docker versions, obviously, right? We should also make sure we keep those versions so that in case if I want to move back to the previous version, it will be easy. If you see, what I'm doing is I'm just getting this build name, build number typically, which says like how many times you run your automated pipeline. So I ran 120 times, okay, because I'm testing so many things. So yes, let's click on build now. It created 121 console output. Okay, it's running. It is actually executing the Python code which I written, And did you see? It is building a Docker image. This is the command that is used to build a Docker, you know, image. As I said, don't worry, I made a fantastic video on Docker. You know how you can deploy the REST APIs in Docker. I also made a fantastic video on the REST API using Flask. I'll keep those links in the video description. So make sure you watch it. It will take some time, obviously, because building images. Okay, by the time, right? If you see, your Jenkins automatically pull this file here. Now, in after some time, there will be one more file comes here, which names with iris. That is typically your Kubernetes file, right? It's actually running. Takes some time, obviously. Oh, now if you see, right, it is actually pushing the Docker. Where is, yeah, this is the place where it build the image, right? And we are retagging it, right? Retagging means like I'm just if you see, the major difference here is, here I'm giving the name as test colon 121. What I retag is Vishwabhanu / test colon 121. That's what I mean by retagging, just changing your name. Now we are pushing this particular image into the Docker hub. Obviously pushing will take time because it also depends on your network bandwidth and all. For my local system too, it has to push somewhere in the Docker hub, right? We'll just try to refresh. It will take time. Yeah, even my net is a bit slow today. You see, the refresh took some time. I think this would be definitely quite interesting for you. And the important point I want to add here, if you see this typical cycle, right, the deployment cycle, or else maybe what I call automated cloud dynastic deployment cycle, right? This is not specifically meant for your machine learning deployment, right? This is a typical generic deployment. In case if you want to deploy any REST API, whether you are using a Python, Java, whatnot, this is a typical typical process, right? I didn't write any specific logic to deploy our ML model, right? That's what I want trying to convey, because that's what I stressed here, right? It's not about the tools and technologies, right? We are not using any new tool, a new technology that meant for your MLOps. We are using the existing tools and technologies to do that. Oh my god, it's taking long time to push your image. Yeah, did you see? It got pushed 1 to 1 a few seconds ago. That's cool. It came out. Now, as I said, one file will get created, right? Typically two files. One is for your deployment. Let me open this. This is the Kubernetes file which I'm talking about, where I mention it here. Generates Kubernetes YAML file and deploy it. The deployment could have happened by now. Where is this, man? Yeah, here it is. Yeah, it is success. Deploy model in the Kubernetes service. Let me quickly show you this. So these are the files. I mean, this, if you see this iris name, right, and the CPU details, where I'm just trying to take from this configuration file, which is being uploaded by a data scientist, right? I mean, anyways, we are not talking much about what do you call Kubernetes file. Now let's go back here and run the same command again. Did you see? Awesome, right? It got deployed. Very cool, right? Now open my Postman tool. I did not open it, as usual. No. As I said, one best part about this Kubernetes, right? The scaling, right? So obviously, whenever there is a sudden spike in your request network, then automatically it will spin one more container for you, right? So one more thing which I want to show you, kubectl delete pod. I'm just trying to delete this pod. Array, come on. kubectl delete pod. It does specific data separate document when passing. Okay. Yeah. Did you see? It says it's deleted. It will take some time to come out. Let me open the another tab. kubectl get pods. Did you see? We had to, when I deleted this, it automatically, oh come on man, it automatically spin one more container for us. That did you see? 9 seconds. These two are created 2 minutes back, and I just now deleted, and it is just 9 seconds back. It created a new container for us. I didn't do anything. It automatically do it for us. That's the best part of Kubernetes. Okay. So next what we need to do? Where's the postman? He is the guy. So as this is a local, right? I don't have load balancer in my local, and obviously it's a bit difficult to configure all this stuff, right? But when you deploy the same, when you have this Jenkins pipeline in AWS, typically EC2 server and all, right? When you're deploying Elastic Kubernetes server, automatically this load balancer will be configured for you. We need not to write any special logic. Even when you talk about Google Kubernetes servers, right? It will create automatically for you. We need not to worry about anything. Now what I want to do next, yeah, I'm talking about the load balancer, right? So as we don't have a dedicated load balancer, we just need to run this. This is the name of my app, which I have given in the config file, right? Where is the command prompt? Just run this. As I said, Minikube is for the deployment, for the developers testing. Obviously, we don't have the load balancer. This is the IP. Now, if I run this, obviously it won't work. Let me replace this with the new IP. Let me run this. Cool, it worked, right? Now, if I shut down this, obviously it won't work. Failed. Now, let me run this again. You will get a new set of port. It was 61271. Now it's 61302. Right? Come on. Oh. What happened? Did I not copy it properly? Where is this guy? Yes, I did not copy it properly. Did you see? It worked. Amazing, right? So we did not write, I mean, as a data scientist or like typically you need not to worry about writing the Docker file, Kubernetes file, everything is typically automated. We just need to know the basics of the Docker, all the stuffs. Now, the interesting part. I know you guys are waiting to see this typical pipeline. So if we go to the configure, this is the pipeline. No worries. I kept this Jenkins file here, this pipeline here. Did you see? This is the way you can pull your code. This is where I'm logged in with my Docker. Obviously, if we want to push the Docker image, for building a Docker image, I don't need credentials. But if I want to push, obviously I need to pass the credentials. And this is where I'm running my Python code. Now, this is the time to see our Python code. That is already also there in my Git repo. Where is this guy? Here it is. Let me open that. The most interesting part is this. Okay, what am I doing here? As I said, the tag, the version of my image where I'm taking from my build number here, right? And if you see, that is the first piece of code. I'm calling get latest build info. So I'm using Jenkins Python package. Using that, I'm getting the latest build number, right? And then what I'm doing, I'm building an image. Where is my Python function here? Yeah, here it is, right? So I'm getting a build number from this, right? And you might have seen here, right? Image name in the logs. Yeah, let me open the logs. console output. Did you see image name, right? So what the print statement will come and print in this Jenkins output log, right? And this is also I'm just trying to run. If you see, running Docker command, right? I'm also writing the logs in the local file to make sure if there are any errors to sort it out, right? And the next step would be tagging the image. That's what I'm just trying to explain here, right? From this name to this name, I'm just trying to change. And then I'm generating the Kubernetes file. Where is this guy? Yes. See, what I did is I created a generic Kubernetes, file as a dictionary. Typically, Kubernetes supports YAML file. Dictionary is nothing but your JSON file, right? So if you see here, right, this is a typical name. This is the sign-in name. But if you see, right, what I'm trying to do here is I'm just trying to read the configuration file. I'm reading a configuration from the wrong place. It's supposed to be read from this place, but that's fine. So see, I'm just trying to rename, right? Metadata name. It was sign in. As I said, I created a generic, the Kubernetes configuration, right? So I'm just modifying my dictionary based on the configuration file uploaded by a data scientist, right? And then I'm writing it. Did you see? So because as we are deploying as a REST API, we need a service. So in Kubernetes world, service is nothing but a network manager, ideally speaking, right? It gives you the IP. So whatever you have seen here, right, that minikube service, right, IRS URL. This service is the one who gives us the URL, right? And then I'm writing these files in, and then our deploy ML. This is the function. It is very straightforward too. What I'm doing is here I'm saying load kube config because this is a local system. In case if it is a cluster, maybe if you want to deploy an AWS GKS, you should be load cluster config. Instead of kube config, it would be load kube cluster config because that's a typical cluster we need to deploy, right? This function name will change, right? And then I'm just okay, for this I'm using this Kubernetes Python package. Where am I? Yeah, here it is. I'm just creating a client with this we just need to import it here. You see client config utils, right? And then deploying image, what I need to do is utils dot create from YAML, right? I'm just passing this this method which I created based on the Kubernetes client. So client is nothing but the agent that helps to deploy your Kubernetes YAML file in a Kubernetes cluster. You can think like that. Of course, I also need to deploy my service, right? First, I need to deploy my container, and then I need to deploy my service. As I said, service is nothing but your network manager, right? And the deployment model is Kubernetes cluster, and that is what our last print statement. All right. I think this is pretty much I want to cover, right? Everything is in the Git repo, right? In case I detailed, I have given a brief description about what this Python code do, what this Jenkins do. Everything is here. I also have the sample, the train model, the prediction logic or whatever it is, which is available in this main branch. And your MLOPS code is in the MLOPS _ code branch. I think I'm good. In case if you have any doubts, you can always comment. And very important things about MLOPS, not about MLOPS, make sure you subscribe to my channel and like the video. Thank you.